Topic 3 covers problems involving proportions. And the good news is we've talked a little bit about proportions already. We talked about proportions when we learned how to solve rational equations. And then we also had a proportion when we were looking at uniform motion. So hopefully this isn't very new to you, but let's introduce proportions, even though we've already seen them. So you do have to remember a ratio is something that just compares two quantities using division. So it's like a fraction, you're just comparing two things. And then a proportion is a statement that says two ratios are equal. So for us, we've already seen where we have one rational expression equaling exactly one other rational expression, and it gives us a shortcut for solving. We can cross multiply. So there's something called the cross products principle for proportions. And it basically says if you have a proportion, that being A over B equaling C over D, if it truly is a proportion, then A over D or A times D equals B times C, assuming B and D are not zero. So that's the whole cross products thing. So we cross multiply and then we use that to solve. Okay, so nothing crazy here. The solving should be familiar to you. We've already done it a couple of times. We just have to learn how to set up the proportion. So let's look at example 6. Example 6 says solve, include units with the final answer. So we have two situations here for part A. We have a car dealership is offering special financing on cars this month. For every $1,000 borrowed, the payment will be $16.67. If Stanley borrows $22,500, calculate his monthly payment. Well, when you're using proportions to solve an application like this, you have to set up one ratio with the information you know without a shadow of a doubt. We know without a shadow of a doubt that for every 1,000 borrowed, the payment is going to be 1667. Okay, so let's set up one ratio using that information. So we have for every $1,000 borrowed, we would have a $16.67 payment. That's going to be our first ratio. Our second ratio is going to be only given to us partially. We're going to use this idea of cross products to find the fourth piece. So the second piece of information that we have is about Stanley. We know that Stanley borrows $22,000 or $22,500. We need to use that to calculate what his payment would be. So the thing with proportions is you have to set up common units horizontally. So if the numerator in my first ratio is dollars borrowed, the numerator in the second ratio needs to be dollars borrowed. If the denominator in the first ratio is the payment, the denominator in the second ratio needs to also be the payment. So we know that Stanley borrowed $22,500. We're going to use that to figure out what his payment would be. We don't know what his payment is. So we have a proportion. We have two expressions set equal to each other. We just want to cross multiply. So I'm going to take 1,000 and multiply it by x. Remember, you multiply the diagonals. So first numerator, second denominator, first denominator, second numerator. So I'm going to get 1,000 times x equals 16.67 times 22,500. Okay, well, 1,000x is just 1,000x. 1667 times 22,500, I don't care to do in my head. So if you've got a calculator, pull it out. And let's see, we get 1667 times 22,500. And that's going to give us 375,075. Whoops. And let me check make sure I don't forget the number. Yeah. Okay. So now what we have to do is we have to figure out what x is. Well, to get x by itself, we need to divide by its coefficient. So we're going to undo the multiplication of 1,000 and x. So we divide both sides by 1,000. 1,000 divided by itself is just 1. 1 times x is x. And then we want to take that 375,075 and divide it by 1,000. Hopefully you can kind of divide by 1,000 in your head, but if not, let's go to the calculator. So we're going to take this previous answer and divide it by 1,000. And we get that Stanley's payment would be 375.075. So let's talk about that for just a moment. So we get 375.075. The issue is we're dealing with money, and anytime you're dealing with money, you have two decimal places. So after the decimal point, you want two numbers. So we need to do some rounding here. We want 2 decimal places, so we need to round. So we're going to round this 7. So looking to the right of the 7, we have a 5, which tells me to round up. That means I add 1 to the rounding digit, which is 7, and then chop everything after that off. So Stanley's payment is actually going to be $375.08 is Stanley's payment. So that's what Stanley would owe each month. So $375.08. So just always know that with money, we don't have to tell you this. With money, you just need to always know that there's 2 decimal places, and we assume that you're just going to round to those 2 decimal places. Okay? Now, next up for part B, we have on a particular map, 1/4 inch represents 15 miles. We know this without a shadow of a doubt. So we know this right here. We absolutely know it. Can't be changed. 2 towns on the map are 3 1/2 inches apart. Find the number of miles between the 2 towns. Okay. Now, because we're solving using proportions, we, the math instructors, want to see the proportion. Yes, you could play around with this and figure out the answer, but I want to see your algebra. Okay. So I want to see what we know without a shadow of a doubt as our first ratio. So I know that 1/4 of an inch, and we could think of that as 0.25 inches if that's easier. So we know 1/4 of an inch equals 15 miles. So we're going to set up a ratio for what we already know. Then we're going to set up the other ratio with the piece of information that we know, and then we're going to let a variable equal the piece of information that we don't know. We know we have 2 towns. We know they're 3 1/2 inches apart. We don't know how many miles that is. Now, just remember, common units have to line up horizontally. So if inches are in the numerator of the first ratio, inches need to be in the numerator of the second ratio. So 3 1/2, we could think of that as 3.5 inches. Now, in both of these cases, the 1/4 and the 3 1/2, I wrote them as decimals because the decimals are easier to work with. And I can do this because these are decimals that terminate. If we had like 1/3 or 2/3, we would have to work with the fraction there. All right, so we have 0.25 inches over 15 miles equals 3.5 inches over x, x being the number of miles between these 2 towns. We need to go ahead and cross multiply, so we're going to multiply along the diagonals. So I get 0.25 times x equals 15 times 3.5. So I get 0.25x equals, we can go to the calculator. Let's see what we get. 15 times 3.5 is 52.5. So we get 52.5 here. And then I need to get x alone, but my issue is it's being multiplied by 0.25. To undo that multiplication, I divide both sides by 0.25. Well, 0.25 divided by itself is 1. 1 times x is x. And let's see what we get here. We want to take the 52.5 and divide it by 1/4 or 0.25, and we get 210. So that tells me these 2 towns were 210 miles apart. And that's it. So the good news is solving proportions is fairly easy. You're always going to be given one piece of information completely. That's going to be your first ratio. And then the second piece of information you're only going to get half of. That's going to be your second ratio. Just make sure your common units line up horizontally, cross multiply, and solve.